The objective for today is to simplify square roots. This skill is simply an advanced version of finding square roots of numbers. You already know your perfect squares. We went over that in class the past couple days. So today we're going to look for and make use of structure when we're simplifying these radical expressions. So we're going to use the structure, the same similar structure for every single problem that we end up solving. So let's get a little bit of warm up in. We know the square root of 36 is 6. So this is just warming us up with some square roots that we're used to. The square root of 100 is 10. So now we're going to end up having problems like this one, where we need to find the square root of 63. 63 is not a perfect square, but we can simplify this. Okay, so if we have something like the square root of 63 that's not a perfect square, how are we going to simplify it? Well, the first thing we need to do is think about the factors of this number and figure out which factors are perfect squares. So let's go ahead and list out the factors of 63. 63 is 1 times 63, 3 times 21, 7 times 9, and then 9 times 7, 21 times 3, and 63 times 1. We already have those, so we don't need them. I'll list it again. So 9 is a perfect square. So that's my factor that's a perfect square. And in this case, it's my largest perfect square. That's the next thing we need to look at. If there's multiple factors that are perfect squares, you want to choose the largest perfect square. Okay, so now that I know that my factors that I'll use are 7 and 9, I can now rewrite this radical as 7 times 9 instead of square root of 63. So I'm now going to, instead of square root of 63, I'm going to write square root of 9 times 7. It's the same thing because 9 times 7 equals 63, so I can substitute that in. Okay, so I rewrote that radical. I rewrote the square root of 63 as a product of the factors that I chose. All right, moving on to our third step, I'm now going to separate this. So I'm going to write it as square root of 9 times square root of 7, and then I can simplify. I know that the square root of 9 is 3, so I can rewrite this as 3 times the square root of 7. And so 3 times the square root of 7 is going to be the simplified version of square root of 63. So that is the answer I'm looking for on these problems. So let's go ahead and try a few examples. I have the square root of 48. So until I get a lot of practice with this, I'm going to go ahead and write out all my factors. So I'm going to write out 1 times 48, 2 times 24, 3 times 16, 4 times 12, and 6 times 8. So those are all my factors of 48. On this one, I have two different perfect squares. I have a 4 and I have a 16. Well, 16 is the largest one, so I'm going to use 3 and 16 when I rewrite this. So this will be square root of 16 times 3. And now I'm going to separate my perfect square out. So I have square root of 16 times the square root of 3. And now I can simplify. The square root of 16 is 4, so this is going to be 4 times the square root of 3. That's it. I'm done with this problem. Moving on to B, I'm going to work this problem just the same as I did the previous two. And then I'm going to have a negative sign in front. So for now, I'm just going to pretend that negative sign isn't there because it's not going to influence the first couple steps that I'm going to do. The first thing I need to do is write out my factors. So I'm going to keep doing this until I get better at being able to just see the perfect square. So 96 would be the same as 1 times 96. 2 times 48, 3 times 32, 4 times 24, 6 times 16, 8 times 12, and then my numbers are going to start repeating. Okay, so my perfect squares are 16 and 4. 16 is my largest perfect square, so I'm going to use 6 times 16. And I'll go ahead and rewrite this. So the square root of 96 is equal to the square root of 16 times 6. I'm going to separate my square root, or my perfect square. Square root of 16 is 4, and then I have a square root of 6 at the end. And then don't forget we still have that negative out front, so I need to make this answer negative. So the simplified version of this is negative 4 times the square root of 6. Notice on these I've been putting the whole number in front of that square root sign. That's the correct way to write these numbers, so make sure you're writing your numbers in that order. Okay, moving on to C. Let's go ahead and try this without writing out the factors. So when I see 72, the first thing that comes to my mind is 8 and 9. I know 9 is a perfect square, so I'm going to try that out. So I'm going to write this as the square root of 9 times 8. Separate my 9 and my 8. Square root of 9 is 3, and then I have a square root of 8 tacked to the end of that. Looking at this, I see 8, and I notice that there's a perfect square that goes into that number. So that means that I'm not done with this problem, and I need to simplify it further. So what that means is there was just a larger perfect square that went into 72 that we did not choose. That's okay that that happened. We just need to make sure we make up for it by continuing on and simplifying this further. Okay, so for now we're going to be working with the square root of 8. So let's ignore that 3 for now and then deal with it once we get square root of 8 simplified. Square root of 8, I know, is 4 times 2. 4 is a perfect square, so I'm going to rewrite this. And then I can separate my 4 and my 2. So my square root of 4 becomes 2, and then I have that square root of 2 on the end there. Don't forget that we have that 3 in front that we just kind of forgot about. So this is actually 3 times 2 times the square root of 2. So I need to multiply my 3 and my 2 to get 6 times the square root of 2, and that's my answer for this problem. Now let's go ahead and move on to D. So this one has some division, but we can break it up to make it seem a little less scary. So this is really just saying the square root of 81 divided by the square root of 121. Well, I know the square root of 81 is 9, and I know the square root of 121 is 11. So I'm going to write this as 9 divided by 11, and that's simplified. I can't simplify the fraction itself. I have no more radicals to worry about, so I'm done with this problem. Okay, for this next one, I have -3 times the square root of 12. Just like we've done in the past, for now let's worry about the square root of 12 and then make sure we add on that -3. We multiply it once we get square root of 12 simplified. So I know 12 is 4 times 3. So I can rewrite the square root of 12 as the square root of 4 times 3. Separate my 4 and my 3. So that becomes 2 times the square root of 3. And then don't forget, we have that -3 out front that we need to multiply. So -3 times 2 is -6. And then I have a square root of 3 added on to the end. All right, let's do one more problem together. I have 5 times the square root of 45. Once again, let's not worry about that 5 for now, and let's focus on the square root of 45. I know that 45 is 9 times 5, so I'm going to rewrite it as square root of 9 times 5, separate out my perfect square, and then simplify the square root of 9 to 3 times the square root of 5, and then we need to make sure we multiply that 5 through. So 5 times 3 is 15. Then I have the square root of 5 added on to the end of that.